In this video we will see what is a magnetic field due to a straight filamentary conductor, So let us assume that there is a current carrying conductor which is carrying the current in this direction, okay, and we will define before that some axis. So we will axis for this. So let us assume that the current is carried in along z direction. So this is the z axis. So along z axis the current is carrying along z axis, and maybe this is the origin O, okay. Now I want to find what is the magnetic field at this particular point. We want to find what is the magnetic field at this point. So the current carrying conductor can be shown like this. It is having a length A to B, okay, it is having the length A to B. Now I want to find what is the magnetic field at this point. Now let us consider a small differential. Let us consider a small differential element dl. So you see here the current is going up. Actually the current is going up. So we will consider a small differential element dl bar, okay, and you know this dl bar is nothing but dl, that is the magnitude, and it is the direction is al, okay. Al is the direction. In this case al is equal to, because since the current is going to the z axis, so it is going in the direction of z axis. In our case actually al is equal to az, okay. So that you have to note down. Now we will see what is the what is the magnetic field at this point. Let's say this is the point P. So first of all I will join with a vector. I want a distance vector anyway. So I will be joining here from the point of consideration. My point of consideration is this particular point to my point of interest, that means P, where I am going to find the magnetic field. So this is my vector r, and the magnitude of this vector r is given like this, okay. So I hope it is clear to you. Now we have my dl is my vector dl, which is equal to some dl into al, okay, or I can say my dl bar is equal to, what is dl? Since I am considering a small portion in the z axis, you see I am considering the z axis and the current is going along the z axis and the length is along the z axis, my dl this become dz and my al become az. So this is my dl in this problem, dl bar in this problem. So dz into az. Now you know that what, according to the Biot-Savart's law, we will get the dh is equal to 1 by 4 pi I, okay, then dl bar cross r, vector r, divided by the magnitude of vector r, the whole cube. So first of all we will find, we have already got what is dl bar, okay. I will write it down. So dl bar is equal to dz into az. So we got this, okay. Now we have to find what is vector r. So what is vector r? So what is vector r? So first of all, you see I am considering the point like this, okay, and sorry, I will use the same color that I have used in the previous page. So you see here I have used the yellow color for the axis. So this is the z axis, okay, and this is my, okay, so this is the point of interest, okay, this is the point of interest. So where I want to find the magnetic field, okay, this dh. Now the current carrying wire is from A to B, okay. Now this is the origin, the current carrying wire is from A to B. Now let us assume that the perpendicular distance, let us assume that this is the perpendicular You see this is 90 degrees angle. The perpendicular distance from the point of from origin, or not the origin, actually this is the line which is carrying the current. We can say the line which is carrying the current is this much. So this is from A to B. So if I extend this line, and if I extend from my point of consideration to this particular line, then I will get 90 degrees. So from the 90 degree distance, that means the orthogonal distance is given as rho. So this distance I am giving as rho, and this direction is nothing but the direction of rho. So I can represent my point R as, let us consider I have my dl bar here. So now I can represent this vector R as I told you. So the vector R is nothing but, let us say this point is, this point I told you this is P, let's say this point is some T. So how to find the vector R? Vector R is P minus T. Okay, so this is equal to, what is the point P? First of all, the point P, you see this is at rho, and what is the direction? A rho. Then what is the Z? You see this is at the origin, so Z equal to 0, and phi can be any value. The phi can be any value. So in this case we are not focusing on the phi, so it is nothing but rho into A rho. Okay, rho into A rho, and or I can say represent like this, it is rho some phi and Z equal to 0. And what about T? T is the point where rho equal to 0, because you see it is along Z axis. Then can we have same phi and Z? So what is your Z? Z is this height actually, so this is your Z. Okay, so P minus T is nothing but, you will get it as rho phi 0 minus 0 phi Z. So my vector R I can represent it, you see rho minus 0, it is rho, and what is the direction? The direction is A rho. Then phi minus phi is 0, so forget about this. 0 minus Z is minus Z into AZ. So this is my vector R. So I got my vector R. Now what is the magnitude of vector R? Magnitude of vector R is nothing but rho square plus Z square. Okay, square root of rho square plus minus Z square is the square root of, sorry, the square of minus Z square is Z square whole power 1 by 2. So we got the main terms in the Biot-Savart law. Now we can represent my dH as, dH is equal to 1 over 4 pi I. What is my dl? My dl is nothing but dz into az. So dl bar is nothing but dz into az cross, what is my vector R? You see next is vector R. We have got vector R. Vector R is equal to rho a rho minus z a z, then divided by, what is this? We have magnitude of vector R, that means rho square plus z square whole power 1 over 2, that is vector R. But in the formula, you know, this is nothing but whole power 3, right? So in the formula it is whole power 3. So the magnitude of vector R, the whole power 3 is nothing but rho square plus z square whole power, this is R is whole power 1 by 2. So we have to take power of 3 also. So this become whole power 3 by 2. Okay, I hope it is clear. So this become whole power 3 by 2. Now we will find what is the cross product. Okay, so you know that we are using now cylindrical coordinates for this. So we have three unit vectors, a rho, a phi and az. So in this case, to find the cross product, you can draw like this. Now you see the first term az cross a rho. So AZ cross A rho, what is this? AZ cross A rho, you are taking this one and this one, so AZ cross A rho become A phi, okay, A phi. Now next is AZ cross AZ, that is equal to 0. So we got it, dH is equal to 1 by 4 pi I. Next we have dz, AZ cross A rho, it is equal to A phi, and also there is a rho here, okay, then divided by rho square plus z square whole power 3 by 2. The second term will vanish because AZ cross AZ is equal to 0. I hope it is clear. So you see how to get the value of H now at the point P. So you see here, this is the, sorry, how to get the value of H. So to get the value of H, we have to integrate the dH, then we will be getting the value of H. So for before integration, what we have to know clearly, you see here, this is my point, this is the point of consideration. That means I want to find the electric field, sorry, the magnetic field at this point, okay, and the current is carrying along z direction, and this is my A and B, and this is my small current element, this is nothing but dl, okay. So this is the current element. Now let us consider the angle, and this is r. Now let us consider this angle is alpha. Now in order to perform the integration from A to B, we can use cleverly, we can use some idea. You see here, I have joined from A to the point P, and this angle is alpha 1, and I have also joined from point B to point P, and this angle is alpha 2. So AB represent the element, AB represent the filament, okay, the filament, the current filament AB can be represented by some parameter which is changing, that means alpha changes from alpha 1 to alpha 2, okay. So we will represent everything in terms of alpha, and you know that this distance is rho, okay, and this distance is z. So we can represent in terms of alpha. So we will remove the terminology, actually we will remove the term z. So the term z will be removed. How we can remove this? We will be representing everything in the terms of rho and this alpha. So you see here, the direction of rho is a rho, and what is rho? Actually this is the 90-degree distance. You see here, if I extend the line, it is the 90-degree distance to the point P. Suppose if you have a big line like this, and suppose if you have a current filament like this is the current filament. So now you want to find what is, this is your point P, then what you have to do? You have to just extend and find what is this perpendicular distance, then that is the rho. So be careful in mind. So this is the direction of your AL, and this is the direction of your rho then, okay. So I will explain this further upon the end of this video, okay. Now you see here, what is tan alpha? Tan alpha is the opposite side, that means the rho divided by z, or I can say my z equal to rho over tan alpha. What is 1 over tan alpha? It is the cot alpha, it is the cot alpha. So we got z is equal to rho times cot alpha. So I have the previous equation which contains dz. You see the term is dz. So what is dz? So dz is equal to derivative of cot alpha, that means rho into minus cosec square alpha. So rho into minus cosec square alpha d alpha. So this is my dz then. Now we will see what is the other term, that means rho square plus z square. So rho square plus z square, which is equal to whole power 3 by 2. So what is rho square plus z square? Rho square plus z is equal to rho into cot alpha. So rho z square will be rho square plus rho square into cot square alpha. This is whole power 3 by 2. So this is equal to rho square into 1 plus cot square alpha, the whole power 3 by 2, which is equal to rho square into 1 plus cot square alpha is cosec square alpha whole power 3 by 2. Okay, so I can represent like this. This is equal to rho square cosec square alpha whole power 1 by 2, then whole power 3. This is what? Whole power 3 by 2. So this is equal to rho into cosec alpha whole power 3, because whole power 1 by 2 is rho into cosec alpha whole power 3. This is equal to rho cube cosec cube alpha. Okay, now we can substitute all this in the previous equation. In this equation we can substitute everything. So we can substitute this. Now you see dH is equal to 1 over 4 pi I, okay, 1 over 4 pi I into dl, that is that dl we have already substituted. Okay, that is I into dz into rho. I will write again, I into dz, okay, I into dz into rho divided by rho square plus z square whole power 3 by 2. This I can represent now as 1 by 4 pi I into rho into what is dz. You see dz is equal to rho into minus cosec square alpha. So rho into minus cosec square alpha, then d alpha divided by, you see this is rho square plus z square, we have already seen it is nothing but rho cube cosec cube alpha. Now the terms will cancel each other. You see here this become rho into rho square, and rho cube will cancel, and this is cosec square and this cube will cancel. Okay, so what is dH? dH is equal to 1 over 4 pi, then minus sign will be there, okay, into d alpha, okay, d alpha divided by rho into cosec alpha, okay, d alpha. And so this is the final term. But maybe one more thing will be there. There is a phi, I didn't write it here, so a phi also, so here also a phi, so a phi also will come. So I hope this part is clear to you. So now we can find, we got AH is equal to, I will just write it, minus 1 over 4 pi minus 1 over 4 pi into I, okay, into d alpha divided by rho, okay, and 1 by cosec alpha is sin alpha. So I can represent 1 by cosec alpha as sin alpha. So this become I by rho into sin alpha d alpha, because 1 over cosec alpha is equal to sin alpha. So because of this reason, okay. So I can find my h is equal to integral of dh, which is equal to integral of dh, and you know that in this case alpha is changing from alpha 1 to alpha 2, because the length is changing from A to B, so angle is changing from alpha 1 to alpha 2. So alpha 1 to alpha 2, alpha 1 to alpha 2 minus I over 4 pi into rho sin alpha d alpha. So this is equal to the integral of sin alpha. So this become minus I over 4 pi into rho integral alpha 1 to alpha 2 sin alpha d alpha. What is the integral of sin alpha? Integral of sin alpha, integral of cosine is sine, integral of sine is minus cosine. So this become minus I by 4 pi then integral alpha 1 to alpha 2 minus integral become actually integral of sine become minus cosine. So, minus cosine alpha, and alpha changes from alpha 1 to alpha 2. So, minus minus will cancel. So, we will get h is equal to I over 4 pi into rho cosine of alpha, and the limit is from alpha 1 to alpha 2. This is equal to I over 4 pi into rho cosine of alpha 2 minus cosine of alpha 1. So, this is the final formula. So, h is equal to I over 4 pi, okay, I over 4 pi into rho into cosine of alpha 2 minus cosine of alpha 1. So, this is the formula. Now, we will see a special case if the current carrying wire is infinite length. If the current carrying wire is of infinite length. So, we will see now, this is my z axis, okay, and this is the point of consideration where I want to find what is my h, and this was my wire, this is my wire. Now, my wire is extending to infinity, and it is also going here to infinity, and the current is going in the same direction. So, it is going to minus infinity. So, what will happen if I take the values? You see, if I am going to infinity, my alpha 2 tends to 0, and you see the alpha 1 is the angle in this way. So, this is the alpha 1. So, alpha 1 will tends to 180 degrees. So, I hope it is clear. So, when alpha 1 will be tending to 180 degrees. So, you have to note that alpha 2 is the, if you take this triangle, so this is the point where you want to find h, alpha 2 is inside, and what is that alpha 1? Alpha 1 is outside. You can consider in different ways also, but this is the notion I usually use. So, alpha 1 is outside, okay. So, in such cases actually you see here, so always remember this, alpha 2 is inside and alpha 1 is outside. So, if it is infinite length, if the wire is infinite length, we have seen that alpha 2 tends to 0 and alpha 1 tends to 180 degrees. So, in such case what will be h? H is equal to I over 4 pi into rho into cosine of alpha 2. What is alpha 2? 0 minus cosine of 180 degrees. So, this become I over 4 pi into rho into 1 minus cosine of 180 is minus 1. So, this become 2 I into 2 divided by 4 pi into rho, which is equal to I over 2 pi rho. So, h is equal to I over 2 pi rho. This is for the wire with infinite length, okay. And what is the direction? We have seen the direction is a phi. So, the direction is not changing anyway, the direction is a phi. So, what is a phi? We have seen if the wire is like this, so from A to B, then if you want to find at this point P what is the magnetic field at this point, then what you have to do, you have to extend the wire, then you have to find what is this perpendicular distance to this wire after extension. So, this is 90 degrees. So, this is rho. The direction of a rho is like this, and the direction of the wire is AL like this. Then the magnetic field will be going inside. That means you can use this rule of thumb, actually the thumb rule, right hand thumb rule. If you do like this, you will get it. So, what is this a phi? So, the magnetic field will be going inside. So, what is my direction of the magnetic field? A phi is equal to AL cross a rho. So, in the problems it is very easy. You want to find what is AL and you want to find what is this a rho. After getting it, it is very easy to find what is the direction of the magnetic field. So, I hope it is clear to you. Thank you.